Hello class, today I'm going to show you how we can draw 3D truss. Let's open Workbench. This 3D truss is going to be a small bridge and we are going to analyze that bridge using beams. Okay, our ANSYS is ready. Open structural design section. The material is going to be default material, which is structural steel, and yield stress is 250 megapascal. Okay, it's good to know. Let's open geometry. Okay, ready. Selecting the grid we want to work. XY is better. I don't want to have a polar dimension, so I select Cartesian dimension. And the bridge is going to be very large, so millimeter unit won't help me. So I'm going to File, Option, select units. For the length I want to be meter, and the minor grid spacing is going to be 1/10. Much better. Okay, now let's have 2 meters height for this and 1 meter to the right, and done. Because I can't use my escape key, if I press my escape key, my video recording software is going to stop, and I repeated this several times. So instead, I'm going to select selection key instead of pressing escape. Let's select these two lines, create move, and press control key and copy this one 2 meters away. Let's select again, move tool, press control key, copy it, this time 4 meters. Okay, it's enough. Now I want to draw the same figures at the other side of our bridge. So I need to have another grid at the other side. So for that, I'm going to right click, use move grid option. Move our grid. Let's move it 3 meters and start drawing the same pattern we had for the left side of the bridge. This time I'm not copying it, I'm just drawing all of them. But you learned how to copy. Okay. Again, let's finish drawing. So left side and right side beams are ready. Now I need to draw the cross members. So right click, select new sketch plan. Now I'm going to select this plan. For the button, I'm going to have rectangle. As you can see, when I'm getting closer to the area, we have other member, it is going to show me. And the other side. Done with this. This is the bottom surface. Now I'm stopping the drawing, and I would like to draw the crossing members at the top of the structure. So again, right click, move grid, this time upward, and it is going to be 2 meters. Let's draw the lines. You need to be careful, exactly select the tip of those structures, because you can select the other parts which won't be helpful. This one and this one. You can see 3 meters distance and 180 degree, which is correct. 2 meters, 90 degree, correct. 3 meters, 90 degree. This one is 92 degrees, so I haven't selected good one, proper position. Now it's 90 degree. One more here. Now we are done. So we have one surface and a lot of lines here. Okay, let's go to the prepare and select the profile for us. Let's select circular profile for this case. Okay, the profile is created here. I'm going to rename it to circle M. Right click, edit profile. We only have diameter for this case, so I'm going to increase the diameter to 0.1. Here we are in the profile editing section. You can close this or just move to the design part section. Okay. Now I'm going to select all the lines by selecting the first one and pressing Shift key and selecting the last one. Now if I go and press create, it is going to create beams for us. If I open the beams, you're going to see all those lines are converted to the beams using the profile I already created, which is circle M. You could have other profiles for different beams, which you can manually change them. Okay, now I would like to select all the beams and convert it to a component, all of them. But here I can't select all of them. For that, you need to go to the design and press select tool. Click the first one, press the shift key, click the last one, right click, move to a new component. Let's name component M. If you click component, you are going to have this share topology option here. Let's use share. As you can see, we have other options, group and merge. What is the difference between these options? You can see the details about these options here at the Space Claim online website. You can see that merge, okay, and share is exactly like the merge, but we have extra imprints for the bodies in contact with each other. and groups are the bounded and the components into the. So we look for share or merge, one of them. For now, I selected share. Basically, this topology share of topology makes all those beams as a one component with multi parts, and they are connected. It's like a welded to each other. Okay, let's close this and go to the model. Okay, our project is ready here to analyze. Let's see what we have here. First thing, we have a question mark close to geometry. If you open the geometry, you are going to see surface has a question mark. If you click that one, it is going to ask you for a thickness. I'm going to give 5 centimeter thickness for the bottom surface. Now it came with green tick. The other part is connection. We don't have any connection defined here. So I'm going to right click, insert, manually create a connection for us. So let's select this bottom surface, hide it, use vertex selection to select all these points using Control key. So these are going to be part of contact. Apply these contacts, right click, show all bodies. Now those points are supposed to be in contact with the left and right side of the bottom surface. Now I'm going to select line selector, select left side, control, right side, and apply the target. Now you can see we manually defined connection between the truss and this bottom surface. And the type is already selected as a bonded, which means they're kind of one body. When there's a stress at, for example, this part, the stress is going to continue inside the surface body as a one body. They're not separated. Okay, let's have a default mesh. Okay, good enough for now. Later we may change it. And for the supports, I'm going to apply fixed support for the side and displacement support for here. And the dimension the axis I'm going to limit this displacement support would be y-axis, so 0 for this, and for x and z it is going to be free to move. Okay, so up to now we have two supports, fixed support for the left side and displacement support for the right side. Let's add pressure here. Apply the geometry. Let's go with 0.01 megapascal. If it was too much, I'm later going to change it. For the solution, deformation and equivalent stress would be enough. Let's solve and see what type of behavior we are going to see. So we could have much higher pressure. Let me increase this pressure to 0.5 megapascal to see what is going to happen. Too much because it's above the yield stress. So 0.2. Still above yield stress, so 1.5. Okay, it's under yield stress. Yield stress, I think it was 250 megapascal. This one is 246. Why I did this one? Because when we consider the safety factor, I want to have a not very large safety factor for this. So stress concentration and the highest stress are close to these two areas, left and right side, and lower stress close to the fixed support. Deformation at the center of the surface, mainly toward the displacement support, is much higher, about 21 millimeter. But what about beams? We don't have any information about beams. So I'm going to right click, insert, beam tool, and have the beam. Let's solve it. Now we can see the stress over these beams. This one and this one, they have higher stress. So at the close to the support, both supports, we have higher stress. The blue one is the compressive stress. This one is because it's positive, it is going to be tensile force inside it, which is interesting. Let's see what else we can add. We can have force reaction for fixed support, also force reaction, this time for displacement. Let's solve. So the reaction force for the fixed support is upward, and also for displacement, which is this is the one we expected. We don't have any other force in x or z direction, so they must be at those directions. Okay, let me go for the probe. What else we can add? Okay, the next result we are going to look for would be axial forces. Let's select axial forces and run. These are the axial forces we have. The highest one are these two, red and green one, red and blue ones, and the middle one has much lower forces. Also, we can add bending momentum. The highest bending momentum would be here, because the fixed support is this side. So for the displacement support, we have higher bending momentum. Let's add shear diagram too to check. Okay, for shear diagram, we need to select a path. To select a path, I'm going to come right click over geometry, insert, not here, model, insert, and construction geometry. Right click over construction geometry and select a path. We can have 2 points path, but here we are going to select edge. So let me select line selector, select this one and this line, and apply geometry. So I defined I defined a one path for our shear momentum diagram because we need to select a path. So the path is ready, and we can solve this one. As you can see, this is the total displacement diagram, total bending diagram, and total shear force diagram for the path we selected there, which is very interesting. Later you can export and get all these data and investigate them. Okay, the next one is going to be safety factor. Let's insert stress tool and stress. We are going to have safety factor. Let's solve, and as we can see, our safety factor is about 1, which is not enough because I intentionally increased the pressure to get very close to the yield stress. So if I go and decrease a bit pressure to, for example, from 0.15 megapascal to 0.1 and solve this problem, we are going to have a much better stress safety factor. As you can see, safety factor increased to 1.5. Still, it's not acceptable. So maybe we could have 10 times smaller. Yeah, safety factor is about 15, very safe, but I think it's about 5 or 7 would be very good design. Let's see, stress, play the stress. For the deformation, let's play the deformation. If you wanted to export that video, you can use this export video file button and use it for in your report or presentation. Okay, it's enough. Thank you for watching. See you next time.